Okay, so before the break, we were looking at SVG Graphics, scalable vector graphics. It's kind of the standard for 2D vector graphics. They used to be very, very important on web pages, but back when transmission speeds were very, very limited, when everybody was on dial-up internet, because it took forever to send a picture. So especially for like logos and things, we could really condense the data. To get that situation, some situation like that, we use both. To keep clarity, no matter what the size is. Vector graphics these days are mostly used for more complicated things than just drawing simple pictures and logos. We'd use it for, since it's recalculated every time, they're great for animations. Anymore, we don't really track it. Y'all have probably seen where you can take a video of somebody walk in and get lines drawn on them, show all those movements, sort of a basic skeletal structure. Whenever we have vector graphics, whether 2 or 3 dimensional, we can give those shapes a skeletal structure, and the equations describing that shape can adapt to the motions of the skeleton. So it makes animations a whole lot easier, because then we don't have to draw every single frame in an animation. We just use vector graphics to recalculate it and then give some defining points on how a skeleton would move, and then the shape just follows the skeleton. Makes animation super easy. We can do that with some of the other image types, the database ones, but they tend to stretch and pixelate and lose aspect ratios kind of bad when we do that. But if it's simple movements, it can work with the other ones, or break it down into like little bitty pieces. So instead of just the shape, a picture of a character, you have like a picture of a character's hand, and a picture of the character's forearm, upper arm, and the torso in like 3 or 4 different pictures, a whole bunch of pictures. Then the skeletal structure can move those pictures around independently without it getting really bad. But scalable vector graphics, it just recalculates for whatever the motion defined was. But like we saw right before the break, it took a lot to just type in a simple thing like that. We probably want to use some software. So for several years, I've been using this one, Inkscape. There's a lot of them that will work. GIMP's a very popular graphic software, been around for a long time. It will work with scalable vector graphics. GIMP actually draws scalable vector graphics, and the default version is to transfer those to a ping afterwards. This one keeps things in software. Inkscape keeps it in scalable vector graphic format. I'm going to resize this. Oh, then this is the right size. What was that? Maybe I just need to zoom out. Where's that no zoom? There we go. So that's sort of the picture size it's drawing, and then we can put fancy shapes on there. I'll do the ones that we saw, like a box, and there's a new color. Maybe a little circle up here. Make that yellow. I'll just gonna draw a tree shape. Oh, that didn't close out. I got too big of a hurry and didn't get that closed up. Drag this one over here where it closes. Oops. Or is it just set to not have that anything filled? Oh, okay. The fill was turned off. Make that brown and got the pencil again. Something like that. And fill that one with green. There we go. Just a quickly drawn picture. So the stuff that you're probably familiar with from drawing software elsewhere. We can still select each one of these shapes, move them independent of the other ones. Put it down just a little, something like that. And they're all independent shapes. So if I go ahead and save this picture, I'll save this. And the thing I like about this software, there's a lot of versions of it. The nice thing about this, the thing I really like about this software is the scripts are done in Python. So if you want to do your drawing, write some code to help automate some of that drawing process, or add new buttons or something, it's done in Python or C++. But Python's the one most people use anymore. I always call it drawing.svg. But you'll notice that here on my computer, at least, the SVG files, by default, they get that Google Chrome icon. So it's going to try to open with Google Chrome. Sure, that works. And when we saw this before, it created an XML file, but then gave us that SVG tag. So we probably want to move that SVG tag over to our thing. What I was wanting to look at is if we zoom in, it's like before, no matter how much we zoom in, we still have all that clarity. It's just a whole lot easier to do with the mouse. Yeah, I'll open that with Adam, make a comparison. Open drawing. So we can just copy, oops. Don't collapse that. We can just copy all this and paste it into an HTML page, no problem. It'll work like that. We can convert it to another one. You see a lot of that stuff that we saw, the width and height of the box, and a bunch of other stuff. Eventually down here, we get those things we saw, so like a rectangle tag or an ellipse tag, which just an elongated circle instead of a circle. And then a path. Which is just all these different points. So you notice there's a point, there's a point, there's a point. So it's all the points around on a polygon, and then once it was a path, just set to fill it in. Yeah. Yeah. Fill in whatever shape that makes with the color I clicked on the button there. And then a whole bunch of XY points, like it was a polygon. It was all for polygons. So another common markup language that we will see around the world. There's lots of software that can be used to handle that. Where did I go? Oh. I switched to using this one a couple years ago, mostly because I like how it was. Everyone who scripts, it's in Python, which is a much easier language to work with than Visual Basic. You just really like Adobe. Illustrator is the equivalent of Illustrator. Has all the same buttons. It was even developed by some people that used to be on that team, but the scripting in Python can be a really nice feature. But there's no shortage of software that can do that. Just want to look for something that can create SVG graphics. You want to use those. Makes it a whole lot easier than writing that in code, usually. I wanted to look at a couple other markup languages real quick. A common one that really I haven't seen it starting to work anywhere into education yet is speech synthesis markup language. So things like Polly or Google Assistant. Polly's Alexa's voice. We can just write down the words as a text file and they'll read them all. But only so well, right? They'll read them off sounding like a machine. So we use a markup language for most of those. It's the same one that gives us other little points along the way. Oh, there's things to listen to. I should probably share the sound when I share my screen this time. There we go, share sound. Now share the screen. There's some short ones. So you'll recognize the markup language, the opening and closing tags. And it would just rattle off the words, but might hit a problem when it hits something like this. Like it might try to actually pronounce that. So we want to make sure and have the computer voice say that those are letters, or pause for a certain amount of time. This is how Google wants it. You have to pass it into the Google Assistant as HTML typed into the text value on a JSON object. So you have to put your HTML into another language code to pass that. But these are the ones I was looking for. So just
My SSML content.
You see, it would read off the words. I need to turn that down here to remind me. Lately, nobody's talked. If there's anything to say, it shows up in the chat room. So I didn't realize how loud that speaker right behind me was. Or if I turn that down a little, does the other volumes go the same way? Nope. I turn it down one at a time. So we can have it pause, like taking a breath.
Step 1, take a deep breath. Step 2, exhale. Step 3, take a deep breath again. Step 4, exhale.
And some of these you can probably guess, like the changes. I think we can edit that. Oh, I thought we could edit those. But take pauses along the way and different types of breaks. Those are the things where you can make the Google Assistant sigh and grunt. And I think I pulled up a video last week about that where it where they were using Google Assistant to fool humans and would make mumbling and growling and sighing sounds. So we use a markup language to do that. And doing Google Assistant, and I might as well say Alexa, because y'all wouldn't know the other terms, but Alexa and Siri all use this same markup language. So anything else that wants to do that probably at least needs to be compatible with the standard, right? If the three big ones do. So I wanted to point it out somewhere because I can see this being if you're getting into software development now, this is something I can see you needing before too long. It hasn't really showed up in academia anywhere yet. So just Google SSML. Speech synthesis markup language, and you can take a look through the tags. All of that should look familiar. hear what they're doing. I'll select say as unit.
10 feet.
So notice 10.
A, B, C, D, E, F, G.
And different ways we can make it say things. Oh, the dates are kind of nice.
The 10th of September 1960.
So very different than the text written on the page. And we need a markup language to tell the computer how to read those things. That was really quiet, but there's a huge collection of sound effects already built into the language, so we have the tags for it. Or we can add our own just with an audio tag, which you can see looks exactly like the audio tag in HTML. Have it pronounce things when it sees an abbreviation.
World Wide Web Consortium.
That would be the words that it actually said to speak, but it's not how it says it. Y'all can look into that, but I like to use this class as the introduction to markup languages in general, and this is one you will definitely see coming up before long. One other markup language I want to look at now, which that's one you're going to want to Google and spend a little bit of time looking into, because that's definitely going to be prevalent in our world before long. I can do it on Docs. I go to my Google Docs, have a plugin for this. So, y'all have probably noticed before that I'm going to go ahead and erase this because that was from before the break. Y'all have probably noticed before that sometimes the way we would write things in math class might not work so well when we have typed text to work with, right? So 3x minus 7. So the square root of all of that as a fraction over, I don't know, 4 alpha, 4 gamma, that'll work. I'll use lambda. So square root of 3x minus 7 over 4 times lambda. That's how we would write that in a math class, right? Hopefully writing a messy one like that doesn't make anybody panic. Don't need to solve it, just talking about writing it. But if we needed to put that on a keyboard, like type that into a document, our keyboard's not very friendly for that, right? There's definitely not a square root symbol. We don't have a lambda key, which is where the next one I want to look at comes from. So quite a few years back, somebody was writing a big math paper, a computer expert, who knew a whole lot about computers back in the day too. So it was still kind of more of an electrical engineering thing, and the computing part was new, but it was getting to the point that they could do a little bit more. And he was putting together this big math paper. And one of the things he needed was some Greek letters. In particular, he was talking about some statistics, so he needed to do a chi-square test. So he needed to write the Greek letter chi. And well, obviously, that's not a letter that's on our keyboard. So he checked around with other people, checked with people at large, like, how can I write a chi into this paper? And person after person after person kept telling him, just use an X. Just use an X. And he was getting really, really mad because this was a big, huge math paper. So the letter X was already written all over it. He didn't want to use an X. He needed something that was specifically different than an X. So finally he decided there wasn't a good way to do it, so he created a language called Tech. I know it looks like X, but it was over his anger with the Greek letter pi. It's like a K, pronounced like a K, not like an X. So we pronounce it Tech, because yeah, people kept telling him to use an X, and he finally got mad and just wrote his own way, made his own notational thing, which is passed around as a markup language. And it was improved later into LaTeX. So an improvement on it, which is another common markup language, but it's different than the markup language we were seeing. That's why I want to look at this one, because those tags with angle brackets, that's not the only way we can do a markup language. Markup language really just means we have some special symbols. So if I share my screen, I have several plugins to work with LaTeX, so I'll just use this one. But those angle brackets, like we've seen, aren't the only way we have to do markup languages. Markup languages, it just means we have a special symbol that the computer will interpret. And it's not like a dynamic programming language where we have keywords and the computer will do a whole bunch. It's sort of like keywords or key symbols that are already pre-programmed in the computer. We can't change what they do or anything. The ones in our dynamic programming languages, we can change. The markup languages, we just need special symbols to indicate things. So like here is that formula, that awful looking formula I just wrote on the board. So from that sentence, you kind of know what I'm about to write, right? We need this, the square root of the quantity 7 less than 3 times x, all divided by 4 times lambda. So it looks like a mess, but this markup language LaTeX is pretty much the standard for doing mathematical stuff. So, and this one, it's the most common one to use it. The first symbol we use in markup, indicated markup, is $2 signs. So that when we write $2 signs next to each other, that's the LaTeX markup symbol for stop showing text and start showing mathematical notation. Then we can do fractions, and we tend to write things in inside of curly braces, some spaces, and then our other markup is we use the backslash all over the place. So it looks like escape sequences from other languages, but it is still a markup language because it's that special symbol going with a keyword. Right? Hopefully you can see how backslash over is in the same family as if we had the over tag like we've seen elsewhere this semester. So that gives us a way to write a fraction. And then again, $2 signs to finish out the LaTeX thing. Throw on the board, or it will be in a minute. And then I have this button here to render all the equations that are in that sentence. So just that little markup symbol indicated that we're going to a fraction there. That's a quick way to get a fraction. And well, there's a render and de-render button, which y'all can see there. So you can kind of turn those on and off as needed. So I wanted that thing on the board. Definitely not a square root symbol there on our keyboard. So again, our markup is the backslash, and then we group things inside of curly braces. So like 3 times x minus 7 is what's on the board. And on the bottom of the fraction, I want to have 4 times lambda, which is a common Greek word, so I can just once again use that special symbol to indicate I want that Greek letter. So our markup is quite different. We have this key symbol. The standard one is $2 signs, but LaTeX has been working to a lot of different things. So that start writing math notation might be different in different software. Actually, the other add-on I have here doesn't need the dollar signs. It gets a little place to type it to the side, and then leaves all this as alt text. But so a dollar sign is our markup symbol to say, okay, this part isn't text anymore. This is going to be something different, math notation. And then our standard in it is we use the backslash and a keyword to indicate what we want. So like backslash word for a square root, backslash over to say we have a fraction, or backslash any of our Greek letters to say we have a Greek letter. Then when we render it, you can see that it gives us a very nice rendition of that on there. Also makes an easy way to type Greek letters if you want those. Oh, whoops. That's right. And on the Greek letters, we can switch between a capital and lowercase just by the letter there. That's a trivia point, but it gives us really nice math notation as a markup language. And the reason I wanted to look at it was because it's very different than all the other markup languages we've seen. So as the example of the angle bracket thing isn't our only markup language. Anytime that we throw special symbols inside of other stuff, like inside of text, one we've been looking at this semester, we kept adding more and more and more text, so that our text was inside of the document. So we intermingle the text we want with some special characters. That's considered a markup language. So I thought I'd use LaTeX as the example for that, so that we can make nice looking math equations, because our keyboard is not very user friendly when it comes to math equations. So a couple more markup languages there. It's something we see quite often in multiple places. So next thing, our final thing today, I'm gonna go back to this file we were doing the other day. Oh, wait. Both of these files. Okay, I'll open them from over here. I don't seem to have an edit with Atom button, which is odd. I guess I have to make my own. There we go. So the other day we were looking at animating things with CSS. Doing some extreme cases, but it kind of works to show the point. Generally, you would want to do subtle effects on this. So if I throw in a subtle effect, something like oh, that worked. We have that thing where it's growing. So if I do the section tag with the hover pseudo selector, so that when our mouse is over it, Then I can call that animation growing thing. And animation duration, let's say 5 seconds. So we saw that the other day. We just need the name of it, how long it's going to take, and we make that name by using @keyframes. Oops, did not mean to collapse that. We're using @keyframes, giving it a name, and then we have 2 sections we need to fill out: the from and the to. So where does it start and where does it end? Normally we do stuff more like this, very subtle things. So you guys have to wait for it to finish animating. There. Oh, once the green goes away. So when we hover our mouse over it, I was looking for the one that changed size. Did I just type in the wrong name? Okay, I'm not sure why it's doing that. I was trying to get to change size, but hopefully y'all see and get the point there. It's usually for more subtle things that we want it to do. Green. Let's see if that one does. When I hover over it. Oh, yeah. Have to wait for the previous one to finish. And then when I hover over it, it slowly changes colors. That would probably be better as a size thing. I don't know why the size thing was wanting to spin. I must have gave something the wrong name yesterday. We looked at those basic ones. Set up our keyframes, give it a name. What CSS properties and values does it start at? And what values do those CSS properties end at? And then we just say how long it's going to take. We can do some other stuff too. So what is this one? This one grows and spins. So if we need to customize it a little bit more, we can do things like change the direction. We get normal, which is just forward, or we could spin it in reverse. Before I save this, so you can see it's spinning clockwise. So now I'll save the file and reload it. Make it spin counterclockwise. Which can also be useful to go through the animation and then go back to where you started. Which that is alternate and alternate reverse. So alternate goes through our animation the first time, spins clockwise, and then it should go through it the other direction. Is that the one I wanted? I'm gonna make that shorter. And I'm gonna get rid of this. That however didn't work like I'm meant for it to anyway. Or alternate reverse. Oh, I know why that's not going more than once. Because in order to do that, to alternate, we need to run our animation more than once. By default, it only runs it once and then stops. That is, so to make it run more than once, we have the animation iteration count. Say 4 times. So then it goes through that forward once, then backward once, and forward. It should go backwards one more time. So by setting multiple iterations, we can go through it forward and then switch afterwards. What else do we have here? We can change the speed along the way. I'm going to comment those out. Just showing the different ones. Alternate dash reverse is the reverse. That is, like in this case, it would go backwards first, so counterclockwise, then clockwise, counterclockwise, kind of back and forth. So these are just little additions we can add on there. So it's just back to where it was, like 4 seconds. There we go. So here's one time through our animation. Maybe we want to change how it goes. So we can also change the timing. So animation timing function. We have a bunch of different options. I'll start with ease. So ease starts slow, and then it goes fast, and then slow at the end. So it like speeds up, and you think of it like driving in a car. Where to stop, so we accelerate to our full speed, and then decelerate at the end. So slow, fast, then slow. I was hoping spinning would have more effect than that. I have to do that on both of them. Okay, yeah, and when there's multiple ones, I have to do it on both of them. So I'm just gonna take one of those away. I'm taking the growing away. That way, there's kind of enough clutter on the screen there already. We don't need multiple things. So you can see the speed changes as it moves along. Linear is just a constant speed. That's the default value. Usually we don't go typing in the defaults. Ease in is a slow start. It takes its time to get started. But then it gets up to the full speed. Obviously, we have an ease out as well. So it starts fast, but then gets slower as it reaches the end. The other option is a cubic bezier curve, which can be complicated. Maybe I should open Inkscape back up. I'm going to go back to Inkscape again, because it has cubic bezier curves. So if I wanted to make a curve, I can draw 3 points there, right? That's probably the first thing you think of with a curve, just 3 points. And that blue line tries to smooth out those 3 points there. A cubic bezier curve is more like this. So there's our 2 points. And notice when I put a third point here, we're gonna get those straight lines smoothing out in between, change what happened between the previous 2 points. If I move this further, notice how the new points are changing what happened before. That's a cubic Bezier curve. So a much more complicated function where they're related, then each new point in the curve is related to the previous points in the curve. So they affect each other. So in the case of, if you want to do a curve like that, you just pass in a comma separated list of numbers that will, they act as a fraction of the time passed. So if we said 4, 8, 2. So in total, there's 14 pieces there. Is 4 plus 8 plus 2 will give us 14. So at first, it'll do, in 1/3 of the time, it will do 4/14 of the animation. And then in the second third of time, it will do 8/14 of the animation. And in the last 1/3 of the time, it'll do 2/14 of the animation. Hopefully that made sense. So we add those up, then take that as a fractional amount, but the number of things we have, it's that fraction of the time. So 3 things means in 1/3 of the time, that fraction of the animation will pass. You see the speed changes quite drastically there, or added in a couple more, so maybe 5 and a 1. So now it's in fifths. So in 1/5 of the time, 4/20 of that animation will go through. And in the second fifth of time, 8/20 of the animation will go through. And in the third, we have 2/20. The 4th fifth of the time interval, which we said was 4 seconds. We can make that longer. Let's make that 10 seconds, so we can see a change. In the 4th fifth of the time, 5/20 of that animation will pass. And same thing there with the last number. Hopefully that makes sense about how that curve changes. So our speed changes drastically as time progresses. It speeds up and slows down and changes drastically over time. That can be a very useful one. Oh, the last one I want to point out, I was expecting to be done about 10 minutes ago. One other little flare function, I guess that's how to call those. The little flare that we add on, just the little extra bits. If I go back to what it originally was, so we had spinning and growing. It took 4 seconds and 3 seconds. At the same time, it's getting greening. We might want to keep that. I think we looked at this the other day, didn't we? Animation fill mode is how does it fill? Maybe we go backwards. So if we fill backwards, it already comes in at the spot it needs to be for the animation. That's really useful for if we're starting off the screen and coming onto the screen. So like if you use the position thing and start way off screen and then move onto the screen for your animation. If you didn't backfill it, it would start on the screen, then move way over and animate back on. So back, in that case, backfill would start as way off the screen. So back, it's like back from before the for. So like the for properties carry backwards to when the page was reloaded. Obviously, there's another one that goes the other way. The forward means the to property continues onto the page, which will probably look better on this one. Yeah, I'll just cut that one. I'll go back to what it was. As it starts, it's only a split second before it starts, but then when it goes through that, it changes drastically at the end. And that animation is unrelated to the final result. So I might want to carry that through. And that's our forwards. So then when it grows and spins and it gets to the end, it's still like those changes. Oh, I'm going to do that on the other one as well. So we can either go backwards, forwards, or both. And the default is none. So back means the properties in the from section continue backwards to when we reloaded the page. And forwards means the properties of the to function or the to section continue forward after the animation stops. Forwards. So we like animate the loading of our page. So things spin and grow and change colors. And then that's how our page ends up once it's ready. Delay as well, right? I have a delay on here. Delay might be another good place for backfilling. So let's make that 2 seconds and animation delay of 2 seconds. So the spinning thing takes 4 seconds. So we're going to wait 2 seconds before we start turning green and then turn green. So it's halfway around and then turns green quicker. So you can see we can mix and match those, add a little bit of flare different. Maybe we want to delay before spinning. Oh, why is that open? I don't need that today. Animation delay. 2 seconds. Then when we load the page, it just waits. I was thinking it would start growing there, but it looked like it. Oh, anyway, it didn't. So there was 2 animations and only 1 number. So it applied to both of them. 0 seconds. There we go. So it starts growing, then it spins, and then change colors at the end. So we can stagger around with those little bits of flare and get some more control over it. Which definitely takes a little bit of practice to get it used to. Oh, oops. So I guess I'll put all of these on that website so y'all can look at those if you need reference stuff. And it definitely takes a little bit of practice, and you might have a few good ideas of how that could what? Oh, go in here. Can I do all those all at once? Oh. I guess I can't do them all at once. Oops. Yeah, so that way, if you go to this site, remember that's a SDEV 153, all that stuff, you can see it on the screen. I believe it's on our Everyline page somewhere too. You can access that example there. It's definitely something that takes practice, but it adds a lot to your animation, to your website. Even if you do very, very small ones, right? Even if you only move your thing 2 pixels over a 10-second interval of time, it adds a lot, especially subtle ones like that. People won't even notice the stuff changing, but they'll be happier with it because it adds a touch of realism or something. I haven't figured out the quite the right words for that. But the same way, like with colors, we don't have a solid distribution of colors the way screens output colors in the real world. Colors change, filter over time. They're not completely flat. So like very subtle linear gradients have a positive effect on the person looking at your website. Very subtle animations like can make a big difference. Or depending on your topic, the animation might just have some animations that are relevant to your topic that make the site look good when you load it. Or click on things or hover your mouse in certain spots. But that takes practice. So that's definitely my recommendation for live time today is practice more with the animations. See what subtle and drastic effects look good on your website. Because well, we're in Module 8 now. About to finish up this semester, there's final projects due, so might also be a good time to work on final projects or anything else you might have coming due soon. Unless people are in more than one class, you might have projects in more than one class, but looks like we have about an hour and a half left for lab time to mess with that. Mess around, do stuff. Please spend our time productively doing something. This close to the end of the semester, I assume you have something to do in most all your classes. Otherwise, does anybody have any questions? That was all I had for today.
I don't have a question about today, but about what we discussed today, but the HTML assignment that's due tonight by midnight doesn't have a place to submit it.
Oh, sorry, I missed the button. I'll go turn that on right this second. Looks like, yeah, you weren't the only person that had that question. Submission, online, file uploads, our website. All right, now you should be able to submit it. Sorry about that. It's an easy button, an easy checkbox to forget to click after thinking really hard about the assignment part and putting instructions together. Any other questions? All right, I think 5 seconds of silence means no questions. So if any show up, let me know. As always, for the next hour and a half, I'm gonna be sitting here waiting to jump back on a Zoom call. If any questions arise, text messages and other messages always on my phone. Otherwise, y'all have a great weekend, and I will see you on Monday to finish up the semester.